Hello, this is AP Calculus Basic class with Mrs. Ryu. Today we are going to talk about chapter 9.3 says the integral test and the p-series. Okay, so let's look at the integral test. If the function is, there are three conditions. Number one is positive. Number two, the graph is continuous. Number three, decreasing for x is greater than or equal to 1. So there are three conditions. Then, and also an equals fn. Then the series and the integral. Either both converge or both diverge. So that means if the series converges, then the integral converges. If the series diverges, then the integral diverges. The reason for that is when the area under the curve converges, the sum of riemann sum rectangles, okay, it has to converge. That makes sense? Okay. Even when the riemann sum rectangles are overestimated, it's the same thing. When the area under the curve converges, then the sum of the rectangles also converge. If the area under the curve diverges, then the sum of the rectangles also diverge. Now let's apply the integral test to the problem. So I have a series n over n squared plus 1, and we're going to decide whether it converges or diverges. Okay, so we are going to check a few things here. Is it always positive? That's number one. Is it always positive? And yes, because n starts with 1, so it's always positive. Is it continuous? Okay, and yes, because the denominator is never 0, that means it's continuous. Number 3, is it decreasing? Okay, decreasing. And yes, because the degree in the bottom is greater than the degree in the top. So yes. So let's find the let's evaluate the integral. Okay, so I'm gonna write x instead of n. X squared plus 1 dx, and 1 to infinity. That's what we are going to evaluate. So I'm actually supposed to write b goes to infinity and 1 to b, right? Okay, so let's use the u substitution. U equals x squared plus 1, so du will be dx, 2x, and dx. So I have u in the bottom, and x dx. Instead of x dx, I'm going to write 1 over 2 du. Okay? So I have limit b goes to infinity, 1 over 2, and I have ln u. Right? So instead of u, I'm going to write x squared plus 1. Okay? And we are going to evaluate this starting from 1 to b. So I have limit b goes to infinity, 1 over 2, and ln b squared plus 1 minus ln 2, right? As b goes to infinity, I get the infinity. So the integral it diverges. So the series also diverges. Okay, example number 2. Let's see if we can use the integral test. So 3 things. Okay. So number 1, is it positive? Because n starts with 1, and yes. Okay. Is it continuous? Okay. Because the denominator is never 0, so yes. Okay, is it decreasing? As n gets greater and greater, it decreases, right? So we are going to use the integral test, and I'm going to write the integral 1 over x squared plus 1 dx 1 to b, and the limit b goes to infinity. So that is limit b goes to infinity in arc tangent x 1 to b. So that is limit of arc tangent b minus arc tangent 1. Okay. So the arc tangent graph looks like something like this. Okay. There is pi over 2. So as b approaches infinity, arctangent b is pi over 2, and arctangent 1, tangent 45 degrees is 1, so that's pi over 4. So the answer is pi over 4. So we can say that the series converges. Okay, but this doesn't mean that the series converges to pi over 4. Okay, the integral converges to pi over 4, but that doesn't mean that the series converges to pi over 4. However, the series converges because the integral converges. Now let's talk about the convergence of a p series. Okay, when you have a series 1 over n to the p power, we call it a p series. Okay, and the p series converges for p is greater than 1 and diverges when p is between 0 and 1. Okay, so here is a simple proof. It says we can use the integral test. So integral, let's say 1 over n. Okay, then I'm going to have ln absolute value of n, and we evaluated 1 to infinity, right? So that diverges. How about square root of n? In this case, p is 1 over 2, right? In this case, is p is 1. Okay. Then I have n to the negative 1 over 2. So that is n 1 over 2 and 2. Okay, and then we evaluated 1 to infinity. So that's divergence again. Diverges. Okay. How about when p is 2? So I can have 1 over n squared. So that's n to the negative 2 power. So we can evaluate this integral. That's n to the negative 1 and negative sign in front. So 1 to infinity. Let me rewrite it. That's 1 over negative 1 over n, 1 to infinity. So in this case, I can have negative 1 over infinity plus 1, so that's 0, so it converges, right? So when p is greater than 1, it converges in this way, okay? But when p is in between 0 and 1, then it always diverges. Okay, so there are 10 different ways to test for series, and then so far we did 5. Okay, so 1, 2, 3, and then number 4 was the integral test. Okay, and number 5 is the p series. Okay, so let's make a summary. A geometric series looks like this: 0 to infinity, ar to the nth power, and it converges when absolute value of r is between 0 and 1. It diverges when absolute value of r is greater than or equal to 1. Okay? By the way, the sum of the geometric series is A over 1 minus R. Okay? Number 2 was the telescoping series. So when you have some kind of a series, Bn minus Bn plus 1, and then when you can keep canceling out, okay, then it converges, right? So I can say that as n approaches infinity, Bn equals L, then we can say that this telescoping series converges. Nth term test is number 3. When you have the series An, let's say, the limit of An is not 0, then the series diverges. Okay, but there's no condition of convergence. Okay. So this test does not show the convergence. It only shows the divergence. Okay. The integral test, you can have sigma An, and let's say the An equals Fn, and they are positive. Okay. Then we can say that 1 to infinity of fx dx, when it converges, the series also converges. Okay, 1 to infinity f of x dx, when it diverges, the series also diverges. The p series looks like this: sigma 1 over n to the p power. Okay, it converges when p is greater than 1. And it diverges when p is between 0 and 1, and especially when you have a sigma 1 over n, which means p is 1, right? This is called harmonic series. It's just a special name. Here is a Bible verse of the day. Isaiah chapter 41 verse 10 says, "So do not fear, for I am with you. Do not be dismayed, for I am your God. I will strengthen you and help you. I will uphold you with my righteous right hand." Have a great day, guys.
Here I am to worship, here I am to bow down, here I am to say that you're my God. You're altogether lovely, altogether worthy, altogether